Hello, to start with today we're going to multiply and divide numbers by 100 and 1000 to give us a little bit of practice at that, and then we're going on to look at the next bit of our work on measurement. So to start with, multiply each number by 100. So remember, if you know what you're doing, pause it, get on with it, check your answers. Okay, so multiplying by 100. So remember, 100 has two zeros, so what we need to do when we're multiplying by 100 is move our digits 2 places to the left so that they get 10 times bigger each time they move 1 place. Okay, so in the first one, if we were moving 1 place, the digits would be there. Remember, the decimal point stays where it is. Moving 2 places, the 4 and the 7 would be there. Remember, you can't have gaps in between your numbers and the decimal point, so you need to fill in with a 0. And because that's now a whole number, we don't need the decimal point. So the answer there is just 470. Okay, the next one. Moving 1 place, the 2 would go here. Moving 2 places, the 2 would go there. And then the other digits have to follow it. 2, 5, 0, 3. And the decimal point would be here, but we don't need it because we've ended up with a whole number. So 2,503. And you see what I did that time was I only looked at where the first digit was going. I didn't bother writing all the rest of them in here, because of course your digits stay the same and in the same order. Okay, the next one, 0.94 times 100. So moving 1 place, the 9 would be there. 2 places, the 9 would be here. The 4 has to follow it. And again, we don't need that decimal point. And the last one, I'm just going to change that to 0.051 before we start. And then when we multiply by 100, if we move 1 space, the 5 goes here. 2 spaces, the 5 goes there. The 1 needs to follow the 5, and the decimal point has to stay in the correct place. Okay, so the answer to that one is 5.1. Great stuff. Right, next, we're going to be dividing each number by 1000. So, remember, dividing, we're going to the right, and because we've got 1, 2, 3 zeros, we're moving to the right 3 places. Okay, so if we move, remember the decimal point, in a whole number is after the numbers, okay, after the last digit. So, to move 1 space, the 3 would go here. To move 2 spaces, the 3 would go here. To move 3 spaces, the 3 would go there. The decimal point stays where it is all the time, doesn't move. And we need a 2 after the point, but we don't need to put those zeros in here because 3.2 is exactly the same size as 3.200. Okay, so the next one, if we move it 1 place to the right, the 4 goes there. 2 places, the 4 goes there. Remember, this is where the decimal point is. So 3 places, the 4 now is on the other side of the decimal point. The 7 and the 5 must follow it. And we put a 0 in front to make the decimal point stand out. So the answer there is 0.475. Okay, the next one, 29. So when we move 1 space, the 2 will go here. Remember, this is where the decimal point is. Move 2 spaces, the 2 now comes after the decimal point. And moving 3 spaces, the 2 goes here. So the 9 has to follow the 2. We've now got a space in front of the 2 where we need to put a 0. And so we need the 0 in front as well to give us 0.029. And then the last one, 3.2, when we move 1 place, the 3 goes here. 2 places, the 3 goes there. 3 places, the 3 goes here. The 2 has to follow the 3, and we can see that we've got a space here and a space here, so the answer is 0.0032. Okay, so here we are with this week's work. So we've looked at units for measurement. So we looked at length, area, volume and weight. Yesterday we looked at length, and today we're going to be thinking about area. So we're on to area today. Excuse me. So what I've got here to start with, we've just got some squared paper, and we're going to say that this, the length of the side of one square is a centimetre. Now obviously it depends on whether you're looking at this on a PC or a laptop or a phone or a tablet. It's going to look a different size for everybody. So let's just say that the length of the side of one of these squares is 1 centimetre. Okay, so if we change this line to make it a square, then that means that that's 1 square centimetre. Okay, so area is measured in square units. Okay, let's go back a little bit and think about what area actually means. So area is the amount of space a flat shape takes up. Okay, so area is to do with two-dimensional shapes, not 3D shapes. Okay, so if we've got a square that's made up of 1 centimetre by 1 centimetre all the way around, then that square takes up the space of 1 square centimetre. And we say square centimetre, not centimetres squared. Okay, so here, if we start off with a line that's 2 centimetres long, and if we make each one of those centimetres into a little square, then this must mean that we've got 2 square centimetres here. But if we make a square out of 2 centimetres and 2 centimetres, then we can see that the area of this shape is 4 square centimetres. Okay, so we can count squares inside a shape to work out its area. Okay, so we're going to have a look at the following rectangles now. So let's look at this first one here. So we could count all the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the area of that shape there, that rectangle, is 15 square centimetres. And we work that out just by counting them. Okay, to be honest with you, I'm not really looking forward to doing this one because there's quite a lot to count there. So can we start thinking about a quicker way of working out how many squares are in here, please? Okay, so let's look at this one next. So counting along the top, we've got 1, 2, 3, 4, 5, 6, 7, 8. Let's not count these individually. Let's realise that that's a row of 8. So that must be a row of 8 as well. So that gives us 16 square centimetres altogether. Okay. So next, look at the one underneath here, this little one. Now this is actually a square, but a square is still kind of rectangle. I've said here, the area of each rectangle, and a square is just a special kind of rectangle. We'll get onto that a little bit more next week. So we can see here, we've got 1, 2, 3, and another 3, and another 3. So altogether, we've got 9 square centimetres there. So without me counting all of these squares for this rectangle, how can I work out how many squares are in there? Well, first of all, let's count how many squares there are along the way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's a row of 10. So we've got 10, 20, 30, 40. So it's 40 square centimetres. Can you think of an even quicker way that we could have worked out that rather than going 10 and 10 and 10 and 10? Well, if we think about it, that length there was 10 centimetres, wasn't it? And this one here is 4 centimetres. So this is a box or a rectangle that's made up of 4 lots of 10 centimetres. So in other words, what we could have done is just done 10 times 4. And that would have given us 40. Let's just check that that would have worked with this one. Remember that was 8 across. So 8 times 2 is 16. 5 times 3 is 15. And 3 times 3 is 9. So what we've found here is that if we multiply the length and the breadth of a rectangle together, the number that we come up with is its area. So we're going to have a little look at these two rectangles here. And we can't count squares here. We don't need to count squares anyway because the measurements are given to us. Okay, so what we're going to say is to find the area of this rectangle. Remember, we need to do length times breadth. Okay, and does it matter when we're going to multiply two numbers together? Does it matter what order we do it in? Well, the answer is it doesn't matter. Okay, so we do it in the order that is easiest for us. Okay, so when we get on to using formulas a bit more, what we'll be looking at is how to write this out correctly. Okay, so I'll just show you just now and we'll do it for these two. So we write A equals L times B, because that means area equals length times breadth. And then we write down the numbers that we're going to multiply. So we're going to do 1.8 times 3, and remember it doesn't matter what order they go in. Now to work out 1.8 times 3, I'm just going to do it at the side here. So 8 3s are 24. 1 3 is 3, add the 2, makes 5. We've got 1 decimal place in the question, so we need 1 decimal place in the answer. That means a decimal point has to go there. So equals 5.4, and we need to remember our units. Because we started off with centimetres, then our area is in square centimetres. Okay, and it doesn't actually matter if this rectangle was drawn to scale or not, because it tells us what the lengths are. So in maths, if it tells you it's a length, that's the length that you take it to be. You don't bother measuring it. Okay, so the next one, again, we're going to write down our little formula. A equals L times B. So length times breadth. So we're going to do 23 times 11. And again, we're going to do this at the side. So we'll do 3 times 11 is 33. 2 times 11 is 22. Add the 3, makes 25. So this is equal to 253 square centimetres. Now, if we had started off with millimetres for our lengths, then our answer would have been in square millimetres. Or if we'd started off with just metres, then for our length, then our area would have been in square metres. So whatever your length is, it's the square version of those units that you use for measuring area. Okay, now I'm just going to have a little look at estimating the area of irregular shapes. So we don't have a formula for working out the area of a blob. So what we need to do is, first of all, we're going to have a look inside this shape and we're going to count all the whole squares. And I'm just going to put a little mark in all the squares that we've counted that are whole. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 2, 3, 4, 5, 6, 7. I'm going to say that one is a whole one, 28, 29, 30, 1, 2. I'm going to say that's a whole one as well, 3, 4, 5, 6. So 36. Okay, I've got 36 whole squares there. So the next thing we're going to do is we're going to see if we can match up parts of squares that make a whole one. Okay, so for example here, if we look at this square down here, that one is almost a whole square, it's just got a corner missing. And this one here is actually, tell you what, look at these two. That bit there of a whole square and that bit there, they match together, don't they, make a whole one. So we've got a whole one there. So we're going to say we've counted them. And this is what we're going to do. We're just going to go through and make a whole one. And each time we make a whole one, we'll write it down. So let's see. We've got just over half a whole one here, so let's find one that's just less than. So maybe this one here, so those two would make a whole one. Then we've got quite a bit of a whole one here, and that would make almost a square, wouldn't it? Then, so all we're doing is we're just going through, and each time we're trying to put together, like this one here and this one here, whole squares. Okay, so this is almost a whole one. We need to find one that's got a bit, so we'll use that bit down there. Oops. Then we've got that one's about half and that one's about half, so there's another one. Then we've got, let's put this one and this one together. Then let's see, this one, and we need just a little bit, so we'll have that one. Then this one is almost a whole one, so we need a little bit to go with that, so there we go, that's about a whole one. This one is very nearly a whole one, so we only need a tiny bit. Have we got one that's got a tiny bit left? Let's see, that one. Then we've got, if we have a look what's left, we've got this bit here, and that one could go with that one there. Then we've got that one that is over half, and this one is less than half. Then the bits that we've got left now, we've got this one, this one, this one, this one, this one, and this one. Let's see, is that all we've got? I think so. So let's put this one here together with that one there. Okay, so that one and that one actually make just over a whole one. So now we're going to just have a look and see, can we make just less than a whole one? And I think if we put that and that together, that makes just less than a whole one. They cancel each other out. And then what we've got left here, I think that and that probably make about a half. Okay, so I think we've got all the bits and pieces, and if we just add them up, so we've got 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 50 and a half. So I reckon we have estimated the area of this blob to be 50.5 square centimetres. So we're never going to be able to get that completely accurate because we're not measuring those bits and we're not putting them together to make sure that they make a whole square. But that just gives us a way of estimating an area. Okay, so that's great stuff. That's us done for today. So I will see you tomorrow to carry on with our measurement work. See you later.